What am I looking for? Right, I remember. Only Covalent, only Covalent, or an element. Okay, so this is on page 33, 33. Page 33. Ionic compounds. So this is a review of ionic compounds because we haven't done much on them since last day. They are made of positive ions and negative ions, which are called, what do we call the positive ones? Cations. And what do we call the negative ones? Anions. And you can remember that because, of course, the cats have paws. I was really excited to find a little picture of a cute little cat holding up its paw like that, because cats have paws, so cations are positive. A negative ion, or onion, which makes you cry, which is negative. These ions can be, what? Oh, what do all the elements here have in common? They're all positive, but what do all these four have in common? They're all metals. So the cations can be metal ions, and the anions can be non-metal. And so far, that's all we've learned about. However, there's another type that we're just going to touch on this unit and then do more next unit, or they can be polyatomic ions. What does poly mean? Poly means many. So if you look at this polyatomic ion that we have here, how many atoms are in this polyatomic ion? Count them up and tell your partner. How many atoms are in that polyatomic ion? The yellow one. How many N's? One N. How many H's? 4 H's. So altogether there are 5 atoms. But the whole thing, it's an ion, so it has a charge. So you can have a polyatomic cation. You can also have a polyatomic anion. So let's pick one of these. Let's pick this one, NO3 minus. Actually, no, let's do the first one. Let's do the first one. I apologize. Let's do CO3 2 minus. Now you'll notice I got numbers at the bottom, I got numbers at the top. Why is it important that we write them where we do? They mean different things. If it's written at the top with a charge, that's the charge. If it's written at the bottom, that's the number of atoms. Kennedy, could you shut the door for us, please? Thank you so much. Tell your partner how many atoms there are in the polyatomic ion CO3 2 minus. There are 4. There's 1 carbon. There are 3 oxygens, which gives us a total of 4 atoms in that polyatomic ion. Cations and anions stick together because positive and negative do what? Positive and negative attract. There is a special word for that kind of attraction. If I have attraction between the Earth and this pen, what kind of attraction is that? That's gravitational attraction, yes? When you have a positive and a negative charge, that is not gravitational attraction. We call it electrostatic attraction, okay? So the attraction between charged particles is called electrostatic attraction. And if you're planning on taking any AP courses in the future, the AP people, for whatever reason, like to call this also known as Coulombic attraction. So if you're like, I'm happy to wait for that, then you do not need to write this down, right? I'll put a little diamond there. Okay, but electrostatic attraction, that kind of makes sense because electrons have a charge, right? And so it's an attraction between charged particles. What is a crystal lattice? Tell your partner, what is a crystal lattice? If you want a highlighter, help yourself to a highlighter. So a crystal lattice is the thing that looks like this. It is a 3-dimensional structure. And what is alternating? Positive and negative. We go cation, anion, plus, minus, all the way through. What do we call the force, the electrostatic force in between the ions? What is that called? What do we call that force? That is called I heard it somewhere, ionic bond. And in fact, guess what it says over on the right-hand side of the page, but in small writing? The strong electrostatic forces between oppositely charged ions are called ionic bonds. If we have a single unit of an ionic compound, what do we call that? That is called a formula unit. Is it a molecule? What do you think? Ooh, why is that not a molecule? Molecules are held together by covalent bonds. Number two, molecules are made only of what kind of elements? What kinds of elements form covalent bonds? Nonmetals, only of nonmetals. And then the third one is a little bit hard to write down, but a formula unit does not just exist on its own. Like, I can't actually find in nature a single sodium and a single chloride attached together floating around as a happy little pair. Whereas water is an O and two H's floating around as a happy little triplet, right? So molecules have a definite amount of atoms in them. Bye. Whereas a formula unit is just it's a pretend thing. It's just a formula unit is just a smaller part of a crystal lattice. So you would never see this in nature. You would never be like, oh, look, it's little sodium and chloride holding hands, two particles floating around together, happy little pair. Doesn't happen, okay? They would always be in a bigger group like that in the crystal lattice. Whereas a molecule, definitely one oxygen and two hydrogens, not part of a bigger structure, okay? Ions are particles with a charge. Hopefully you remember that from the last unit. Ions, particles with a charge. They can either be monatomic or they can be polyatomic. What does the prefix mono mean? Mono means one. Therefore, a monatomic means what? One atom, made of one atom. Tell your partner, what does poly mean? Poly means many. Therefore, polyatomic means that something is made of many atoms. So what you're going to do for this number 3 here, and I'm going to come around and check on you and see how you're doing, you're going to decide, first of all, if you have a monatomic ion or a polyatomic ion, so M for monatomic, P for polyatomic, or maybe it is not an ion at all, so N for not an ion. How can you tell if something is an ion? Yes, if it has a charge. So if it does not have a charge, it is not an ion at all. So you're going to do that, and then after you've done that, you're going to indicate if it is an ion, whether it is a C cation or a anion. So take a few minutes and try that, okay? Here we go. Okay. Covalent bonding in more depth. Ionic bonding is very well and good as long as we are dealing with metals and nonmetals. However, does it work when we've got nonmetals and nonmetals? Ionic bonding fails completely. For one reason, nonmetals, when they form ions, they are always negative. Could you imagine a negative particle beside a negative particle? Would that work? No. Okay, it doesn't work. You can't have an electron taker with an electron taker and have one of them take electrons and have one of them give electrons, because they both want to take. So rather than taking, what will they do instead? They will share. So we have shared electrons. We have a positive nucleus. And we have another positive nucleus. What is the glue, quote unquote glue, that holds that bond together? Who is sticking to who? The nucleus is sticking to the electrons, and the other nucleus is also sticking to the electrons. Okay, so the positive nucleus sticks to the shared electrons. The other positive nucleus also sticks to those shared electrons. That's the way we would show it with a Bohr model. If we were showing it with an electron cloud model, it would look more like that, where you just have a lot of electron density. In this area here. Yes? So that's our bond. So there's lots of electron density in between those two nuclei. So nonmetals must share their electrons in order that each atom has a full valence shell. Does either atom have a charge? Neither atom has a charge. No one gave electrons, no one took electrons. Okay, and then this is just a little bit nicer picture than some that I've drawn showing the attraction between the shared electrons and the nucleus, because of course, professional people who make drawings can draw better than I can. What type of attraction is that? Starts with an E. Electrostatic. What kind of attraction happens between an ion and an ion in an ionic bond? Between the positive cation and the negative anion, what kind of attraction is that? Okay, so this is electrostatic attraction. If I have an ionic bond, by comparison, and I have a positive and a negative, what kind of attraction do I have there? That's an ionic bond. Electrostatic. Ah. In fact, every single attractive force between atoms, between particles, between anything, they're all electrostatic attractions, because everything is to do with positive sticking to negative. So this electrostatic attraction is a covalent bond, and that electrostatic attraction is an ionic bond. It just depends who is attracting whom. In an ionic bond, it's a positive ion attracts a negative ion. In a covalent bond, it's the positive nuclei attract the shared electrons. And if you want to read about the reason that nonmetals share electrons, well, we'll go over it. If you are not interested in learning about this, you can just close your eyes for a little minute. Okay, so if you're like, okay, I'm totally into closing my eyes for a little minute, you can do that. I'll tell you when to wake up again. The real reason nonmetals share their electrons rather than giving and taking is because nonmetals have similar electronegativities. And if you remember, an electronegativity is the ability to pull on electrons. It's how much they want the electrons. Yes? So rather than a nonmetal pulling really strongly and the metal pulling really weakly, and so then the nonmetal takes it away from the metal, both nonmetal atoms pull relatively equally. And if you have people pulling relatively equally, what do you get? You get sharing. So what I'd like you to do is, if you're sitting beside someone, you can do this. If you're not sitting beside someone, you can just watch somebody else do it. You are going to get a couple of pens, okay? And I'm going to demonstrate this. Do I have a volunteer to be a demonstrator? Yes. Okay, come on up. So we're not going to have an octet of electrons because we do not have 8 arms, okay? So to simplify matters, we're just going to say that we are wanting to, we just got 2 electrons in our outer shell, okay? And to start with, you're going to be the non-metal, and I'm going to be the metal, okay? What am I? I'm a metal. What's Ida? Non-metal. Okay, so what am I good at doing? Giving, and you're good at taking. Okay, so here we're going to, okay. Oh, okay, what kind of bond has just formed? That's an ionic bond. Okay, now she is what charge? Negative, and I am positive. Okay, and now we are going to be 2 nonmetals. Okay, what do nonmetals like to do with electrons? They like to share. Well, not only do they like to share, but they like to take. So we're both going to be trying to take the electrons, right? We're both pulling on those electrons, and by both pulling on those electrons, and she has, right? We're stuck together because of the force of us holding on to those electrons, right? And you can, she's pulling, I'm pulling. There's actually a lot of force going on here. Okay, thank you so much for here. So if you don't have pens that you're comfortable using, you can borrow some of my pens. Okay, you'll need 2 per partner. And like I said, if you're not comfortable doing this, you can just watch another set of partners do it. But all right, thank you guys for your tolerance at this late time of day. So that part there was the enriched part, and we're done with that now. Okay. La la la. La 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 la. I know we have 5 minutes left, but we have 5 minutes left, so don't pack up. Don't pack up. We're not done. No, we're not. No. Covalent bonding most often results in the formation of molecules. Yes? molecules. So if we look, here's a hydrogen, 2 hydrogen atoms form 1 hydrogen molecule. How would we show that single bond in the hydrogen molecule? We would draw a hydrogen bonded to a hydrogen. And what would the symbol for that molecule be? H2. Two fluorine atoms, they each have 1 gap, right? And so they share. How would we draw a fluorine molecule? An F, and then
interruption. If I could please just get everyone's attention for a moment. I'd like to start by thanking all the grade 12s who voted today for this year's valedictorian. And I am pleased to announce that this year's 2022 grad class valedictorian is Sean O. Please help me in congratulating Sean. Thank you very much. Have a great afternoon.
So homework, you are going to, where do we go? You are going to do page 37 and 38. Okay, pages 37 and 38.
I have a question. So, like,
Yes.
you said that, like, 2 negatives repel, right?
Yeah.
Then how are 2, like, electrons
In the same space?
Yeah.
Huh. That has to do with the fact that electrons are both waves and particles, and they occupy different atomic orbitals, and it's more physics than my poor little brain can deal with. Yes?
Yeah.
And there might be more to it than that that's like at a lower level, like that you could understand or I could understand, but I don't know what it is. There is overlap of atomic orbitals. It's just I've sort of over the years just learned to let that part go because it confuses me. I will ask our physics teacher if they have a really good explanation, but I feel like it comes down to the fact that there are these these probability fields. So the electrons aren't actually in the same place at the same time. They're in different locations within their orbitals. Yeah? And they're held to the atom by that positive core. So that's, although they are repelling one another, it's not enough to overcome that attractive force of the nucleus and like just send them flying into space. Does that seem okay? Yeah, okay, good. Hi. You finished everything? Fantastico. Oh, wonderful. Okay. Wonderful, thank you. Oh no.